Hi everyone. Well, we're back, and today is an exciting day because we are actually going to be plotting some epicenters. We're going to do this. I'm going to plot some epicenters on page 37, and I'm going to use the data from page 36. So at this point, you should have already gone through these pages and corrected your work, checked and corrected your work. And these are the distances that I'm going to be using for plotting. And of course, your answers that you got are plus or minus 100 kilometers from these answers. Just for clarification, the reason why this is 1,050 kilometers, this last one for Savannah, is because if you look over here, the difference in arrival times for New York was 2 minutes, and this was 1 minute 55 seconds. So technically, I mean, you might have gotten 1,100 for both. But since this was a lesser lag time, you could have reduced this to 1,050. So that was my thinking there. So let's get to it. So if in your house you have some kind of drawing compass, the ones that we use in school are the safety compass and this white compass. These are the ones that we use in school. You can actually use any drawing compass for this. If your older sibling took geometry, you may have a regular one, you know, with the point on it with the pencil that you swing. Any drawing compass will do. These are the ones that we use in school because they don't have points and they're safety compasses. And these are the ones that are provided on the lab practical for the Regents in June. So I'm going to teach you how to do this. And if you don't have a compass, that's okay. Just watch. And when we get back to school, we will practice this skill. All right, it's not too bad. The hardest part you've already done. So this is actually the easier part. This just takes a little bit of practice. Okay, so our first earthquake number 1, these are our distances. So here's what we're going to do. We're going to turn to this page. This is our map where we're going to plot. Note, we have a graphic scale up here in kilometers. All right, so we're going to use that graphic scale. So the first distance that we need to plot is that we know when we were in Seattle, the seismograph station in Seattle, Seattle was 900 kilometers from the earthquake. So on my graphic scale, see how the compass covers the graphic scale? What I want to do is I want to make a nice dark mark at 900 so I can see it really well. I'm going to show you how to use the orange one first. All right. This orange one swings around this grommet right here. So that's our point of rotation. So we're going to take that and we're going to put it right on the 0. All right. Now you notice this compass has 2 rows of cutout points. So that allows us to get a really precise fit. So if I go to the top row, here's the 900 by the way. If I go to the top row, look how, if I'm going to zoom in a little, look how 900 is actually in between this point and that point. You see how neither one of these points is a good fit? Okay. So what I'm going to do is I'm going to try the bottom row. Oh, look at that. Look at that. See how that hole is exactly on the 900? That's my better fit. So in this case, I'm going to use the bottom row of holes. Okay, so I'm going to put my pencil point in there. Okay. Now what I have to do, I have to take this grommet and I have to put it on Seattle. So I'm going to zoom back out. Okay, and get Seattle into our frame of reference. Okay, and I'm going to lightly drag it. Now, I'm going to lightly drag it. There may be a pencil mark on my paper, but I can erase that when I'm done. So I'm going to, as precisely as I can, I'm going to put this grommet right on the hole, the dot for Seattle. It's hard to do when I'm not right over it. There we go. Put my finger there. And I'm going to keep my pencil point in the hole, and I'm going to swing an arc. Okay. Now, what do I know about this earthquake? Well, I know this earthquake is somewhere on this circle. I know that the earthquake was 900 kilometers from Seattle. So I know it was here, there, anywhere on that circle. What do I need to pinpoint it? Two more sets of data. Okay. So the next one I'm going to do is the earthquake was 500 from San Fran. Okay, so I'm going to erase this. I'm going to erase this. And I'm going to make a mark. 500 kilometers. That's my mark. Okay. I'm going to show you how to use the white one now. All right. This white one has its advantages because I can get close to the rotation here. So that's my axis of rotation. That's my center of rotation. So the way this one works is, okay, this fisheye lens in there, this fisheye lens, I'm going to zoom in a little bit. Okay. I want to put that fisheye lens right on 0. So right there. Okay, I got that fisheye lens on 0. I'm going to hold it. Okay. And then I'm going to move this. I'm going to squeeze this together and move it. And that inner circle there goes right on. See how hard it is to get. There we go. Oh, nope, nope, nope. Right there. Oh, dang it. Okay, so the restriction on this one is, that's a little bit better, right? Is that better? Okay, the restriction on this one is there's teeth that hold it in place. The good thing here is that this hole here allows you to get closer to your pivot point, but what you have to remember is which one you use. So I know I'm going to use the left one. Okay, so the left one is set to the right distance, the correct distance. Okay, so I'm going to zoom out. Okay, the nice thing about this one too is I don't have to keep my pencil in there and drag it because it holds its spot. See that? Okay, so I'm going to take this and I'm going to put it on San Fran. Okay, I'm going to get that fisheye lens right on the San Fran dot right there. And I'm going to put my pencil in and I'm going to swing an arc. One of the drawbacks of this one is it's harder to spin. It has more friction on it, so it's harder to spin. Okay. All right. So what do I know now? I know my earthquake is either here or here. I know the earthquake is at one of the 2 points of intersection. Okay. So now I need my third station to figure this out. I need my third station to figure out if it's there or there. So the third station is Salt Lake City, and it's 1,000 kilometers from the epicenter. All right. So what I'm going to do on my graphics skill, I'm going to erase this. And I'm going to make a nice dark mark at 1,000 so I can see it really nicely. I'm going to go back to the orange one. That's my personal preference, but it's up to the individual. Okay, I'm going to take this and put it right on that 0. Okay, the 1,000 is between those two. Again, my better point is on the lower row of holes. I'm going to take this and slide it to Salt Lake. And I'm going to make an arc. Okay, now, it did not make a pinpoint, did it? It did not make a pinpoint. Okay, that's okay. What I have to look for is a triangle. Okay, is my earthquake here or here? Did this line make a triangle? See that triangle there? I'm going to outline. Actually, I will go over them in colors. Okay, I got one triangle here. That's the triangle. Ladies and gentlemen, that's the triangle. Okay, this out here is not a triangle. This out here is just a wedge. Okay, what I'm looking for is the closest point where all 3 circles intersect. Now, they did not make a pinpoint. In other words, they didn't do this. They did not. I'm going to show you. They did not make this 1 arc, 2 arc, 3 arc. They didn't do that. That's okay. They did this. They made 1 arc, 2 arc, 3 arcs. They made this triangle. What is our best estimate as to the location of this epicenter? Would it be here? Would it be here? Would it be here? No. The epicenter is right in the middle of your triangle that you made. So this is earthquake 1 right there. Okay? That's earthquake 1. That's our epicenter. That's our best estimate as to the epicenter. Now, Mr. Gorman, why didn't you get a perfect pinpoint? Well, because I'm not a cyborg. All right? I'm using paper. I'm using pencil. I'm using the P&S wavetable and the ESRTs. I'm using our handy dandy green sheet. This is not always a pinpoint, and that's okay. You just don't want a huge triangle. Like, you don't want one that big, because if you get one that big, that would be wrong, okay? So that's our best estimate for earthquake 1. All right. So, another thing is I didn't have to draw the entire circle for the third one because I knew I had to just figure out if the earthquake was here or here. All right. So what I'm going to do now is I'm just going to erase the excess because I'm going to plot 2 more earthquakes and show you this skill just a couple of more times, okay? And when I plot multiple earthquakes on the same sheet of paper, you just don't want too many stray marks, all right? Just to make life too confusing, okay? So you don't want too many stray marks. So I'm just going to erase that extra stuff, all right? And we'll do this 2 more times. Okay, so the next earthquake, Denver is 1,600 miles from the epicenter. Denver, 1,600 miles from the epicenter. So there's 1,000, there's 5, here's 1,600 right here. Okay, I'm going to take my compass, put that grommet right on the 0. Up, Look at this time, it's the top row. See that right there? That's a good fit. So 1600, Denver. Okay, there's Denver. Let down. The first circle always has to be a complete circle. I just broke my pencil point, but that's okay. All right. The next one is 1400 from Seattle. 1400 kilometers from Seattle. So now I'm here. I'm right before that 1500. All right. There's a dark mark. I got a better fit on the bottom. Okay. So 1400 from Seattle. So I'm just going to make a partial arc. The earthquake is either there or down there. All right. So I know the earthquake is either here or here because that's where my two circles intersect. And the third one is 1700 from Chicago. 1700 kilometers from Chicago. Okay, so here's 1500, 1600, 1700. Take my compass. That's a bad fit right there. See how it's in between two dots? That's a better fit on the bottom again. And Chicago, 1700. So, oh, look at that. That's nice. Look at that. Look at that little triangle right there. Okay, see that little triangle? Down here, it just didn't work, right? So here's my little triangle right there. That's my triangle for triangulation. And right here, what is that? That is earthquake 2. That is earthquake 2. All right. So our first earthquake is off the coast of California, like Northern California. And our second earthquake is up in Canada. All right. Okay, now the third earthquake, I'm going to have to erase this. Okay, our third earthquake. Let's plot that. Okay, so Denver is 1600 from the epicenter. Denver is 1600 from the epicenter, so put a mark at 1600. That's a nice fit there. Okay, we already had the circle. Okay, the next one, New York is 1100 kilometers from the epicenter. Okay, I'm going to show you how to use the white one again. Again, this is personal preference. You have your choice every time you do this to use the orange or the white. And it's 1100, right, 1100 kilometers. So I can take that one and put it right there. And that's 1100 from New York. Okay, so I put the fisheye on New York. Hold it, and then it's this one, right? Okay. Arrgh. Okay. So I know the earthquake is like here or here, somewhere in this area. Okay. And Savannah, we'll do 1050 from Savannah. So right there. I'm going to use the orange one again. It's easy for me to spin. That looks like a good fit. So 1050 from Savannah. Okay, so now this is interesting. I'm going to zoom in for this one. You had two arcs that were very close to one another. Okay, so here's your meeting point. So you had this arc and this arc and this arc. Can you see the smaller triangle? This is something that you really have to work at. Can you see the smaller triangle? I'm going to trace it. All right, this is not the smaller triangle. This is the smaller triangle. All right, that's a smaller triangle. So here's our, what's the best estimate of our epicenter? Right there. This is earthquake 3. All right, that's the best estimation of our epicenter. Ms. O'Gorman, you stink at this. You didn't get any pinpoints. Yeah, I didn't. Now, I want you to kind of go back to your answers on the previous page. Why didn't we get perfect pinpoints? Here's why, folks. All of these answers are what? Plus or minus 100 kilometers. So if these can vary by plus or minus 100 kilometers, look what that's doing to your plots. Every single one of these tick marks is 100 kilometers. So if you have a plus or minus 100 kilometer window, which you do, each one of these arcs can move by that much distance. So if you take this arc and move it south, what if Savannah was 100 kilometers less? This triangle would have been even smaller. What if Denver was 100 kilometers less? The triangle would have been even smaller. When you have that plus or minus 100 kilometer window, your triangle can vary. Okay? These are all acceptable in terms of size. And this one's the biggest. And that's acceptable in terms of size. What you don't want is you don't want a triangle like yay big on your paper. If you get a very, very large triangle, you did something wrong. Okay? So that's how we plot epicenters. That's how we physically plot epicenters. That's the skill of it. All right, now, the part 2 of this, now that we have all 3 epicenters, and you might want to pause this to figure it out, what do you want to know about an earthquake? If you, oh my God, there was an earthquake. What do you want to know? 1, you want to know where it was. There we go. We know where it is now, okay? Oh, it was, let's see, it was near San Francisco. Really? How far from San Francisco? Where in California? Oh, okay, it was how many kilometers from San Francisco? Well, the way that you do that is you just take a piece of scrap paper and you just do this, right? You mark off the distance just like we do, and then you take it over to your graphic scale. How many kilometers? Oh, it's about 400 kilometers. In which compass direction? It was about 400 kilometers north or northwest of San Fran. That's what we're going to do down here. All right. Using the distance to epicenter information above, the map and the map scale, plot the location of each earthquake. Done. Okay. Finally, record the epicenter location for each earthquake below by identifying the closest city and describing the direction north, south, east, west of that city. So what you're going to do for these bottom 3 is, and if you need to freeze the video, you can. You're going to find out the distance in kilometers from the nearest city and the direction in relation to that city. Okay. And then, if you do have a drawing compass at home, what I'd like you to do is I'd like you to practice this skill. I'd like you to plot the earthquake that's on this page. All right, so use the data on page 34. You're going to have 4 arcs, not 3. You're going to have 4. All right, and you're going to plot this. This is just one earthquake that you're going to plot on this map using this graphic scale. All right, so I hope that this helps, and you will be doing this when we get back to school for sure. All right, bye, guys.